Let's write a simple HTTP server using Golang. So what we're going to do is we're going to have this function called newFakeStore, and it's going to return an HTTP.handler. And this handler is designed to manage a simple inventory system using an HTTP server. We're going to have two endpoints. So endpoint 1 is going to be for listing inventory items. And endpoint 2 is for adding a new item to the inventory. For this first video, we're going to cover the implementation for endpoint 1. And we're going to start by creating a mutex as such. This is mostly for concurrency, concurrent access to the inventory. So what this mutex is doing is it's going to ensure that access to the inventory map is thread safe, and it's going to prevent any race conditions when multiple requests try to access or modify the inventory simultaneously. Next, we want to create an in-memory inventory storage. So we have inventory as a map of string to pointer of items. So this is an empty map called inventory, and it's being initialized here. It's going to store items in the inventory, and each item is indexed by a string key, for example, an item ID, and the value is a pointer to the item struct. Next, we want to create the HTTP multiplexer. So mux equals http.newServeMux. And this is an HTTP multiplexer that's going to route incoming HTTP requests to the appropriate handler functions based on the request URL. For example, let's say the request URL is /inventory. This is going to have a handler func. And a different request URL, let's say /inventory/add-item. This is going to have a separate handler function. And these handler functions and URL paths are going to be defined on this new server mux HTTP multiplexer. Let's create the first handler function. So mux.handleFunc. It's going to handle the inventory endpoint, and we have an anonymous function here, which takes the http.responseWriter, which is going to construct the actual HTTP response. And we also have the http.request, which is the actual request that's coming in that has, different headers and a different body. So now we want to verify, are we actually processing an HTTP GET request? This handler is only going to support GET requests. So if r.method does not equal http.methodGet, we use this http.error in which we pass 3 different arguments. The first is the response writer that constructs the HTTP response. The second is the error message. So /inventory only supports GET methods. And the third argument is the status code. So http.status method not allowed, because we don't support post requests. We don't support PUT requests, only GET requests. So it's going to return this error and status code to the client. In this case, it's the 405 method not allowed error, and we're going to return after this. Otherwise, we want to actually process the GET request. But first, we want to remember to use this mutex that we created, the sync.mutex. We're going to lock and defer the unlock. This is going to ensure that when the mutex is locked, we have exclusive access to inventory map defined here whenever items are being accessed or modified, and the defer statement is going to ensure that the mutex is unlocked when the function exits or if it errors out unexpectedly. Next, we want to prepare the item list. So we have the var items is a slice of pointer to the items, and we're having a for range loop. So the index item in range of inventory, we're going to take items and append to it what we already have in items with the new item that we're currently on in the range inventory loop. So just to break this down a bit further, we have an empty slice items. It's created to hold pointers to item structs. This should be this pointer to item struct. And the code here is going to iterate over the inventory map and append each item to the items slice. Next, we want to sort the items. So the reason we want to sort it is because we want the list operation to be idempotent. That means no matter how many times you run it, it's going to have the same behavior. And with that, we want to ensure that the list of inventory items is always outputted in the same order. And so for slices, we actually have to use the sort.slice method, where we pass it the items and then we pass it how do we sort the items. So we actually want to do it in ascending order based on the items ID field. So we have func ij of type int, and it's going to return a bool, right? So we have return items of I dot ID is less than items j dot ID. So this will sort the slice based on the ID field of each item in ascending order. And to be a bit more specific, this is the comparison function that helps determine the order. If you look at the item struct here, it has a ID and name that are both strings, and it also has a price. So when we're sorting by the ID, it's going to be alphabetical order, but in ascending order. And next we have the encoding to JSON, because we actually want to return the response as JSON encoded items. And this is why we have the encoding/JSON import up here. So if error equals JSON.newEncoder, we pass it the HTTP response writer and the items that we actually want to encode into JSON format. If the error does not equal nil when we're encoding, that means we want to use this http.error method again, passing it the response writer, the error, which is going to be fmt.sprintf, can't encode inventory, and the error message that we faced, and then also the error message that we received when trying to encode the JSON items struct, or list of item struct pointers. So we also pass it the error message here, status internal server error. This is an error 500, and it's just going to add a descriptive error and status code to the response writer. So to be more specific on what this line is doing, we're taking the sorted list of items that we have just finished sorting using this custom comparison function for sort.slice, and we're trying to encode it to JSON format and write the encoded JSON into the response writer that we're passing into newEncoder. And this is it for the handler function for this first list items endpoint, which is really handling GET requests and listing all the items in sorted order as JSON format. And we can actually just return mux. And in a future video, we're going to implement endpoint 2, which is adding a new item to the inventory, which is going to use the post method.